In the previous section, we transferred latest data between the host and FPGA using user-defined I/O variables. By the end of this module, you will be able to describe how DMA FIFOs transfer buffer data between the FPGA VI and host VI. So first, let's talk about the limitations of programmatic front panel communication. So first of all, only the most current data is transferred. So if I wanted to send buffered data, then I wouldn't be able to use this method. Also, remember, we talked about this before, but if you're using large controls and indicators on your top-level FPGA front panel, that's going to take up a lot of FPGA resources. So if you have a big numeric array, for example, that's going to take up a lot of resources, which is not good. Also, one other limitation is when you're using this method, it's mainly using the CPU on the host to transfer that data. So because of this, the transfer speed of this method is dependent on your CPU processor speed. Also, you're going to have slower data transfer rates going from the target to the host. And again, because it's using CPU, it's going to be using CPU on your host computer. So in this section, we're going to be talking about how do you transfer buffered data from your FPGA to your host VI, or the opposite way, from your host VI to your FPGA VI. Okay, so right now let's talk about what a buffer is. For now, let's call it an area of computer memory that stores multiple data items. Okay, so if you want to transfer large amounts of data at a very high rate between your FPGA target and your host, you're going to need to buffer that data. You can't just send latest values, because you might lose some values or you might overwrite some values. So the best way to do that in LabVIEW FPGA is by using a method called DMA, which stands for Direct Memory Access. And this is going to be a transfer method that we talk about in the next few slides. So DMA is a FIFO-based method of transferring data between an FPGA target and host computer. When you're using a DMA FIFO, that's going to consist of two parts. So part of it will reside on the FPGA, and part of this will reside on the host. What's going to happen is you're going to be able to stream large amounts of data between your computer memory and your FPGA. And this is going to be done mostly without the CPU, so it's going to be done very efficiently. When you create a DMA FIFO, it's going to be unidirectional. So if you wanted to transfer some data from the FPGA to the host, then you can create a DMA FIFO that only goes from the FPGA to the host. If you needed something else going, transferring buffer data from the host to the FPGA, then you're going to have to create another DMA FIFO for that. Okay? So this is going to provide better performance because it's not using that many CPU resources to read and write that data. Okay, on this slide, what we're going to talk about is what happens when you're doing a DMA transfer from the FPGA target to the host. So on the left-hand side, we see that we have our FPGA VI, and in this case, we're going to start putting data into this DMA FIFO. Now the DMA FIFO, from there, it's going to go into the FPGA buffer on the bottom left, and then the DMA engine is going to automatically send that buffer data into the memory of the host computer. And then from there, the host computer is going to have a host VI, and the host VI is going to be able to grab multiple pieces of data from the memory. So let's take a look at this. So notice that the FPGA VI is sending one data element at a time, and that's quickly being sent over directly into the memory of the host computer through the DMA engine. And then your host VI is able to grab multiple elements from that memory and get it into your application. Now let's take a look at the relative transfer rates in this DMA FIFO transfer. So if we take a look at the FPGA going into the FPGA buffer, that's going to be happening very fast because that's all happening on hardware. And then let's take a look at the transfer from the FPGA buffer through the DMA engine all the way to the memory on your host computer. So this is going to be pretty fast as well, and that's being handled by the DMA engine. The slow part is going to be when you're trying to read that data from the host buffer into your host VI. Okay, and the reason for that is now you're relying on the CPU for that process. So this is why you see that the host VI is actually reading multiple elements at a time from the host buffer to try to increase that speed. So another thing you need to consider when you're setting up a DMA FIFO is the buffer sizes. So let's take a look at the bottom left. Notice that there is an FPGA buffer size. So that's represented graphically here, but you can also define that in your FPGA project. So you can define the FPGA buffer size, which we'll talk about in a later module. And you can also define the buffer size on your host. So if you don't define it explicitly, by default, the host buffer size will be 10,000 elements or 2 times the size of your FPGA FIFO buffer size, whichever is greater. So you can also set this programmatically, and the way that you would do that is from your host VI. And we'll talk about that again later.